Okay, so yesterday we learned how to determine if something is a binomial distribution, but then after that, we didn't really do much with it yet. Well, that's where today comes in. Today, we're actually going to do some probability distribution calculations, which is very common in real life. Often we all only have those two different outcomes. So these binomial distributions happen a lot in real life. And if you use a calculator, which we are going to use here, it actually doesn't become very difficult to calculate them. You'll notice that this formula right here, if I had you actually calculate that n, the number of success, and the one that we care about is x, which we've been doing, and you do the probability to the x power times q to the n minus x, which is the q is going to be the inverse of whatever your probability is. This ends up being actually pretty complicated as far as calculating it. But we're going to let our calculator do it instead and try to understand what it means. So I'm going to do that with an example. And we're definitely going to be popping this calculator open to do this example, but let me show you on my piece of paper what I do with this. So it says to introduce your class to binomial distributions, Miss Desi gives a 10-item multiple choice quiz. 10 item. There's my N. My number of items is 10. Okay. It says that the catch is students must simply answer A through E for each question. Miss Desi uses her computer's random number generator to produce an answer key, and then she does it. Basically, this is kind of a guess problem. Patty is one of the students in her class. So we're going to let X be the number of Patty's correct guesses. So if there is A, B, C, D, and E, those are all the answers that it could be. The probability that you're getting it right, and that's what we're doing, is the correct answer. Well, there's a 1 in 5 chance. 1, 2, 3, 4, 5. There's a 1 in 5 chance. Okay. 1 in 5, which is a 20% chance. So we're going to use this as our probability of success of her getting it correct. Okay, so in the first one, it says to show that this is a binomial distribution. I'll just verbally do that. So yes, everything's either a success, she got it correct, or a fail 80% of the time she's going to get it incorrect. Then we have a fixed number of outcomes, check. Each question is going to be independent of each other. Yes, that's true because she's just doing a random number generator. So it's independent. It doesn't matter. She could have got A, right? Like it doesn't matter. Then we have the probability of success being the same for each one. Yes, in this one, since it's a guessing one, the probability of success is 20 for each one. So we've done our 4 checks. Now, here's the new part. We're going to find, well, what is the probability that she has exactly 3, probability of X being exactly 3. Probability that she gets exactly 3 correct out of the 10. Okay, so I do want to show you how that would set up in the calculator. Or I'm sorry, in the non-calculated version, just in case you want to use that. You would take your 3, your 10, your 10 factorial, because that's your n, okay? 10 factorial over, and then we would have our 10 minus the one we care about, 3 factorial. A factorial in math means you do 10 times 9 times 8 times 7 times 6 times 5 times 4, all the way down to 1. So you can see this would end up being 7 factorial times 3 factorial. So there's a lot of factorials there. Then you do the probability of success, which is 20%. To the x power, well, we care to the third. Then we do 80%, okay, the other probability, the probability that failed. So we have basically what this is, this makes sense. You have 3 that she got correct, and you have n minus 7, n minus 3, which would be 10 minus 3. You have 7 that you got wrong. 3 correct, 7 wrong, because that's the probability of incorrect. This part is very intuitive, like that makes sense, but this front part, that's known as the binomial coefficient, it's a little bit more tricky to calculate. That's how you could do that, and you can put it in your calculator. Calculators often have this factorial button, and it's actually not that hard to calculate this, but it's a lot easier in the online calculator. So I'm going to show you how to do that, and we're going to do that exact problem. So I'm going to pop open my online calculator. I'm going to put in n is the number of questions. So this was a 10 question. The probability that I'll get it correct is 0.2, 20%. And the one that we care about, x equals, I want to find 3 exactly. Now, you'll notice that it says x equals and there's a drop down. We're going to get into this less than and greater than in a minute, but right now I want exactly 3. And there it is. We have a 0.20, a 20% chance that she would get exactly 3 correct. I could ask you, what's the probability that she would get 2 correct? There's a 30. That's actually the most. More often than not, which makes sense. There's 10 of them. That 20% is going to happen the most frequently, where she gets 2 of them. It would be 30% of the time. Okay, so I have one other type of question that I'm going to do, and I'm going to base it on this one right here. So what is the probability that she scores at least 6? So passing score is 6 or more. Okay, so what is the probability that she gets at least 6? When I write that in math language, which we've been practicing, that's x greater than or equal to 6. Okay, what that really means is 6, 7, 8, 9, or 10, because those are the passing grades. So what's the probability that she gets 6 or above is how I write it. I always am going to be writing this here. And here's why. This is pretty complicated. On here, you could, I think there is a greater than option, but typically what we do for this is in this problem, we would say, well, this is like a normal distribution. These right here, the probability distribution, I'm going to change this to 6 now, but I want you to realize that the way that we have it right now, that's up here and it's only calculating the equal to. You can do the greater than or equal to, and that would be our probability, greater than or equal to 6. What I typically do though to double check to make sure that that's the correct answer is I instead, because our calculators don't typically do this greater than, I actually go up to, so what I do is if I want 6 and above, I need to get rid of 5 and below. You're going to see me do this on homework as well. I need to get rid of 5 and below. All the probabilities add up to 1, like they always have. And whenever we're shading to the right in a distribution, if you think of it that way, we always do 1 minus the probability to the left. That's exactly what I'm going to do. I'm going to do 1 minus the probability of x less than or equal to up to 5, because I want to get rid of up to 5 and below. So that's what I'm going to do. 1 minus this probability up to 5. So I'm going to change this now to 5. And that is what we get. 1 minus 0.994, essentially. 0.994. What we get when you do that, that's 99.4%. 100% minus 99.4%, you get 0.06%. Okay. 0.06. And that's actually I shouldn't do it that way because it would actually be 0.006. 0.006. I was trying to kind of take it to percents at the same time. 0.006. Okay, I'm going to do one more. Well, what's the probability that she would get more than 4 right? More than 4. So that, again, this is how I do it. I do 4 and above. What's the probability that she gets 4 or more, like 4 up to 10? Okay, means that I need to get rid of 3 and below. So I'm going to do 1 minus the probability up to 3, less than or equal to 3. That's what I would do in the calculator. So I'm going to change this now instead to 3 and hit enter. And that probability right there is 1 minus 0.88. Okay, 1 minus 88%. Well, that's only going to be 12%. Okay, 0.12. She would only have a 12% chance, okay, of getting more than 4 correct. 4 or more, I should say. 4 or more. So that's not a good way to do this. 4 or more would still put you at failing, right? So basically, you're almost guaranteed to fail this if you go into a test guessing. That's kind of the moral of the story on this one. Pop over to the answer key slide if you have any more questions. I did all four problems in that video down below.